Okay, thank you. So good morning. What happened on Tuesday? We started talking about concentrated forces in 3 dimensions. And we have the first case. If you are given a force and this force is given with 3 angles, alpha, beta, gamma, and these angles between the force and x-axis. This is alpha. Beta between the force and y-axis. This is beta. Gamma between the force and the axis. This is beta. So the given angles between the force arrow and your axis, x, y, and z. Sometimes one of them is missing. We can figure out the missing one using this expression: cosine square alpha plus cosine square beta plus cosine square gamma equal 1. If you have this situation, your x component for the force will be the force cosine alpha. Your y component of the force will be f cosine beta. Your z component of the force will be f cosine gamma. Make sure you are in this case. We have another case. You have a force passing through 2 points. We will cover this case more in module number 4. If you have a force passing through 2 points and you can figure out the coordinates of the 2 points. We have one more case, which is very important to understand it, is given a projection line. This case will be given with a projection line for your force in XY plane. If you have this case, we have 2 steps. First step, I will break my force between the projection line and your Z axis. The angle between the 2 blue lines, the 2 blue arrows, is alpha. So I'm gonna use alpha in my calculation. This one will be cosine y because it's adjacent to the given alpha. And the other one will be sine, alpha. So you have f cosine alpha and f sine alpha. This is the first step. The next step, I will break the projection line component, which is f cosine alpha, between x and y. So which angle between the 2 red lines? The 2 red lines, we will have angle beta adjacent to the x component. So this one will be cosine beta and the other one will be sine beta. Which one is sine and which one is cosine? The value of the projection line, which is f cosine alpha, f cosine alpha. So by the end, you can figure out the x component of your force, y component of your force, z component of your force. Easy way. This one will be f cosine alpha sine beta. This one will be f cosine alpha sine beta. I'm sorry, this one is cosine beta. And the z component is f sine alpha. Does that make sense? One more time. One more time. We are given this arrangement. We are given F as a force. We are given this projection line. And we are given 2 more angles. First step, I will break my force between the projection line and your Z. Ask yourself a good question. The angle between the 2 blue color, the 2 blue lines, I'm sorry, is alpha. So one of them will be sine, one of them will be cosine alpha. The adjacent to the given angle alpha will be cosine. So this one will be cosine alpha. This one will be sine alpha. So F sine, F cosine. This is the first step. Next step, I will break the projection line component, which is F sine alpha between X and between Y. The angle between the two red lines is beta. So one of them will be cosine beta, the other one will be sine beta. Since beta, which is given adjacent to X, so this one will be cosine beta, the other one will be sine beta. Which value that will be broken? This value, F sine and F sine alpha. This is the value that we are breaking to X and Y component. By the end, we have three components, Fx, Fy, and Fz. The X component will be F sine alpha cosine beta. The second one will be F sine alpha sine beta. The third one will be F cosine alpha. So keep in your mind, if you would like to figure out the three components in this case, we have two steps. The first step, we need to break your force between the z-axis and projection line. Then I will break the projection line component between X and Y axis. If you follow these two steps, you can break your force if you have this case. Also, last meeting, we started to say something about the resultant force. The resultant will have three components. Component in X, component in Y, component in Z. The component of X for the resultant will be summation for all X components of your forces. Component of Y will be summation for all Y components of your forces. Z component will be summation for all Z component of your forces. Since you can get the three components of your resultant, the resultant value itself will be square root for X component square plus Y component square plus Z component square. And also we have alpha, beta, gamma, three angles for this resultant force. The resultant force in 3D will be defined with three angles, alpha, beta, gamma. Each will be inverse cosine, inverse cosine, inverse cosine. The X component divided by R, the Y component divided by R, the Z component divided by R for the resultant. So you will have three angles. Anybody has any question so far? Guys, do you have any questions so far? All good. Perfect. Hopefully. Let's do more examples today. Did I solve this problem before? Example number 8? I think I did not. Not yet. Yes. Okay. Let's do with example number 8, which is the most typical problem in this module. We are given forces at this hook, and these forces are in 3 dimensions, X, Y, and Z. We are given 2 forces, looks like F1 and F2. And we are looking to figure out the magnitude and the direction angles for your resultant force. This is the last part I covered here. We are looking for resultant force and its direction, 3 angles. First step, to be able to solve this kind of problems, we need to break each force to three components, since we are in 3D. So we have how many forces? Two, F1, F2. So I'm gonna start with F1. Force F1. What are the three components for F1? The question at this moment is, your force F1 is case number one, that we are given three angles alpha, beta, gamma between the force and X, Y, and Z? Or is it a force passing through 2 points and you can figure out the coordinates of the 2 points? Or you are given projection line and you can figure out the three components using this technique? This is the most important question you need to answer before starting. Let's go back to F1. Anybody in this meeting can tell me F1, what is given for F1? Case number one, case number two, or case number three? Looks like we are given projection line. Thank you. Yes. Can you look to this line? It's a projection line. It's projection line. It's given for the force F1. So the first step I will start with, I need to break the force F1 between the projection line and your Z-axis. Very easy. And I hope if you can use color pencil in your solution, will help a lot. So tell me, what is the angle available between the two red lines? It's more complicated. We are given many information, many angles, but look between the two red lines. I think we are given an angle equal 60. This one. That means I'm gonna use 60 cosine and the sine 60 to figure out the two components between Z and the projection line. The projection line component will be 300, the force, cosine 60. Why this one is cosine? Because it's adjacent to the 60. And the other one will be 300 sine 60. This is the first step. I broke the force F1 between the Z and the projection line. The next step, I will break the projection line component, which is 300 cosine 60 between X direction, which is in this way, which is negative, and Y direction. Which angle is available between the two blue lines? If you look between the two blue lines, you will see an angle equal 45 degrees, this one. That means the Y component will be cosine 45 degrees because this one is adjacent to 45, and the other one will be sine 45 degrees. Don't forget to put the value of the projection line, which is 300 cosine 60, which is 300 cosine 60. So by the end, I can write the F1x component, the F1y component, the F1z component will equal. F1x component will be in the negative direction of x, negative 300 cosine 60 sine 45 degrees. For the y component, it will be positive direction of y, 300 cosine 60 cosine 45 degrees. The z component from the beginning, 300 sine 60, which is positive direction also. So if you use your calculator, I have 300 times cosine 60 times sine 45 degrees. It will be negative 106.1. This one will be positive 106.1. This one will be 259.8 positive. Or you can write your F1 as a vector like this. Negative 106.1 I, positive 106.1 J, positive 259.8 K. You have these two options to write your component like this, or you can write your components as a vector like this. This is the first step for F1. I broke F1 to 3 components. Looks like F1 is given by a projection line, so I follow the third technique. Do you have any question? We still have F2. I need to think about F2, so I will clean up this area. And focus on F2. If you look to F2, looks like we are given many angles for F2. F2 equal 500. Looks like I have this angle 60 between the force and the x-axis. So this is alpha. Another angle 45 degree between the force and the y-axis. This is beta. And we are given another angle between the force and the z-axis, which is given by 120. So this is gamma. We are lucky because F2 is given with 3 angles ready for you. Alpha, beta, gamma. So I will write here for F2. F2 equal how much? 500. And we are given alpha, beta, gamma. Alpha equal 60, beta equal 45 degree, gamma equal 120. The 3 angles are given between the force itself and the axis, x, y, and z. If one of them is missing, we can figure it out. But all of them are given, so I can say directly F2 in x direction, F2 in y direction, F2 in the direction will be your force 500 cosine alpha. Your force 500 cosine beta. Your force 500 cosine gamma, which is 120. So I can use my calculator. 500 times cosine 60 equal 250. The answer is positive. This calculation gives you positive value. 500 times cosine 45 degree, I got positive 353.6. 500 times cosine 120, the calculator give me negative 250 because cosine 120 give you a negative 1/2. So the final answer will be negative. This is your x, this is your y, this is your z. We have another option. Excuse me. You can write F2 as a vector like this. Positive 250, I, positive 353.6 J, negative 250 K. These are also the three components of your force. That makes sense? Do you think we have more? No, we are done. We are only given two forces, F1, F2, and that's it. And I am done. I broke each force to three components. Let's start with the second step, which is your resultant. Your X component of your resultant equal summation for all X component. Okay, let's go back to the force. The first one, we have this X component. How much? Negative 106.1. Let's go back to this force. We have X component positive 250. If you have more, go ahead and put all of them, all of X components, but we have only two. So negative 106.1, positive 250. I got positive 143.9. If you look to the Y component of your resultant, equal summation for all Y components of your forces. Equal, we have Y component here, positive 106.1. And we have Y component here, positive 353.6. If you have more, go ahead and put all of them, all of Y components together. So the answer will be 106.1 plus 353.6. The value will be 459.7. The Z component of your resultant will be summation of all Z components of your force. Go back to the first force. We have this Z component, 259.8. Positive 259.8. And we have this one, which is, this one, which is negative 250. So the final answer will be positive 9.8. These are the three components of your resultant. But what about the value of your resultant? R equal square root for the X component square, 143.9 square plus 459.7 square plus 9.8 square. So using your calculator, square plus 9.8 square plus 143.9 square, all of them under square root. The value of R will be 481.8. This is the value of your resultant force. Direction angles, alpha, beta, gamma for your resultant. These angles are called direction angles of the resultant. Equal inverse cosine, inverse cosine, inverse cosine. X component of the resultant divided by the resultant. Y component of the resultant divided by the resultant. the component of the resultant divided by the resultant. That makes sense? This is how to figure out the angles, the direction angles of your resultant. So I will start with the first one, inverse cosine 143.9 divided by 481.8. I got angle equal 72.6 degree. Inverse cosine 459.7 divided by 481.8. I got 17.4 degree. Inverse cosine 9.8 divided by 481.8. I got 88.8. This is your final answer. The value of the resultant force and the direction angles of the resultant force, which is required here. The magnitude of the resultant and the direction angles, which is alpha, beta, gamma of the resultant force. This is called a typical problem in module number 3. We are given forces in 3 dimensions. We need to break these forces to 3 components. Each force is broken to 3 components. Then I can figure out the components of your resultant in X, in Y, and Z. I can figure out the value of the resultant. I can figure out the angles of the resultant force. Anybody has any questions so far? Guys, are you still here? Are you still following me? Okay, perfect. Let's do one more example. Let's do one more example from the homework. I will grab one of the problem. Let's start with the, I will give a hint about problem number 4, just a hint. For problem number 4, you will see that this problem exactly like the example I solved right now, this one. If you look to the F2, we are given 3 angles for F2. 60, this is alpha. 60, this is beta. 135, this is gamma. So F1, in a very easy way, can be broken to 3 components directly. Fx, Fy, Fz, and the value of the force is given. Alpha, beta, gamma are given. 60, 60, 135. This is the most easy one for F1. Keep in your mind the first angle 60 between the force and X. The second angle 60 between the force and Y. The third angle 135 between the force and Z. So these angles can be considered alpha, beta, gamma for F2. Looks good? Looks good. For F1, which is 400, looks like we are given the projection line. Can you see it? This projection line. So I will break F1 between the projection line and your Z axis. It's very easy. Just tell me which angle between the 2 red lines. Which angle is between the 2 red lines is 60, this one. So I will break 400 between the projection line and the Z using 60. One of them will be cosine and the other one will be sine. Since 60 is adjacent to the Z, so this one will be 400 cosine 60. And the projection line component will be 400 sine 60. That makes sense? Then I will break the projection line component between the X and Y. y, your y will be negative. Which angle is in between the two blue lines? The angle 20. Which one will be sine and which one will be cosine? The one adjacent to the angle will be cosine, so the x will be cosine 20 and the y will be sine 20. What is your value that you are breaking? I'm breaking the value 400 sine 60. This is the value of the projection line. 400 sine 60. This is the value of the projection line. So by the end, you are able to break F1 to a 3 component in X, in Y, and in Z, as you see. For X, it will be positive 400 sine 60 cosine 20. For Y, it will be negative because this direction is negative. 400 sine 60 sine 20. For Z, it's positive 400 cosine 60. Does that make sense? Looks good. For problem number 4, exactly like the solved examples we did. And I believe it will be exactly like your coming quiz on Tuesday. Let me talk a little bit about this one. Looks like we are given a force F is unknown. I don't know how much. And their angle alpha, beta, gamma is unknown also. But for F1 is given with everything. And it looks like F1 will be a projection line. This is not my problem right now. Oh, let me focus on this one first. Guys, just to give you a hint, if you have a force without any given information to help you to figure out this force, I can assume your force as Fx, Fy, and Fz. That's it. This is for F. Because everything is unknown. I'm not given anything about F. The value, the angles, or anything is not given. So go ahead and assume your F as Fx, Fy, Fz. This is the 3 components of your force. What about F1? F1 looks like it's given like a projection line. Where is your projection line? I think your projection line is here. Is it correct? I think so. So I will break my force between the projection line and Z. Your Z will be down because the force F1 is broken between this one and this one. Which angle is in between the two blue lines? It will be this 45 degree. And this 45 degrees adjacent to Z. So this one will be 750 cosine 45 degree. And the projection line component will be 750 sine 45 degree. Then I will break the projection line component between X and Y. Which angle between the two lines? It will be 30. This one will be cosine 30, and this one will be sine 30. So which component that will be broken? 750 sine 45 degree. This is the value of the projection line. 750 sine 45 degree. So I am able to break my forces to 3 components. Let's do it here. So for F, I have Fx, I have Fy, I have Fz. I don't know about anything here. Okay, what's next? For F1x, for F1y, for F1z. What are the 3 components of this force? It's for x, 750 sine cosine. For y, it's 750 sine sine. For Z, it's negative 750 cosine. So I can find my numbers. Let me do it for you. 750 times sine 45 degree time cosine 30. Your value will be 459.3. 750 times sine 45 degree times sine 30. Your value will be 265.2. 750 times cosine 45 degree, I got negative 530.3. The question is, do you have more forces? No, we have only this F and we have only this F. That's it. The resultant force is given for you. The resultant is given as a vector equal negative 300I positive 650J positive 250K. You must be aware that your resultant is given like this. So this value represent Rx. This value represent Ry. And the third value represent Rz 250. Does that make sense? Keep in your mind originally Rx equal summation of all X component. We have this X component, we have this X component. So I can say if X for the first force plus 459.3 for the second force, the summation of these two components must equal negative 300. Can you figure out the Fx? I can. The X component of the first force, I can. So it will be negative 759.3. Keep in your mind, the Y component is given this value. Y component originally equals summation of all Y components. So we have this Y component, which is assumed, and we have this Y component 265. So Fy plus 265.2 equal 650. So I can figure out the Y component of the missing force. It will be 384.8. Originally, the Z component of your resultant is summation of F of Z. So we have this Z component, which is unknown, and we have this Z component, which is given or known. So Fz negative 530.3. The summation of these equal 250, which is given. So I can figure out the value of Fz. It will be something like 780.3. So the missing force F, the missing force F, I figured out the three component of this force. The Fx, the Fy, the Fz for this force. Fx equal this value, negative 759.3. Y component equal 384.8, I think. The Z component equals 780.3. If you are looking for the force itself, the force itself will be square root for these components square. So I can figure out the value of the force. Let me do it for you. Under square root, the value of the force will be 1154.7. This is for F. If you would like to figure out the three angles, alpha, beta, gamma, for this force, which is not given, the alpha equal inverse cosine for the x component of this force, negative 759.3 divided by the force itself. So I can find alpha. Beta equal inverse cosine the y component of this force divided by the force itself. I can find out the beta. Gamma, it will be inverse cosine for the z component of this force divided by the force itself. I can find out the gamma. So this problem is a little tricky. This problem, I can summarize it for you. We are given two forces. Force number one, nothing is given about F. And F1 is everything is given. So I can break it to three components. That's fine. But for F, nothing is given about F. Nothing is given for F. So I can assume F as three components. Fx, Fy, Fz. Your resultant is given. The resultant force is given like this vector. Negative 300I, positive 650J, positive 250K. That means this one is Rx, this one is Ry, this one is Rz. Keep in your mind, Rx originally equal this component plus this component. So I can say this component plus this one equal negative 300. So I can figure out the missing one. Also, Ry originally equal this component plus this component. So this one plus this one equal 650. So I can figure out the missing one, the missing component. Also, Rz originally equal this component plus this component for the forces. So this one plus this one equal 250. So I can figure out the missing one. So by the end, I can figure out the three components of your force. Then I can figure out the force itself. I can figure out the angles for this force as well. Any question regarding this problem in the homework? Problem number 2 will be the same, exactly like problem number 3. Let me go through it quickly. We are given two forces, F1 and F2. F1 is the most easy one because it looks like F1 is given by projection line. This is your projection line, sorry. So I will break this force between the projection line and your Z. Looks like the angle between the two red lines is 50. So this one will be 60. The force cosine 50, the angle. And the Z will be 60, the force sine 50. Then I will break the the projection line component between X and Y. The angle between the two blue lines is 30. So this one will be cosine 30, and this one will be sine 30. Which value are going to break? I'm going to break the value of the projection line, which is 60 cosine 50, 60 cosine 50. So from this step, I can break the F1 to 3 component, F1 in X, F1 in Y, F1 in Z. The X component will be negative 60 cosine 50 cosine 30. You can get it. The Y component will be 60 cosine 50 sine 30. You can get it. For F1Z will be negative direction. This direction is negative 60 sine 50. You can get it. So I can break F1 to 3 components. Unfortunately, nothing is given about F2. F2, nothing is given. So I can assume F2 to 3 components. I can break it to 3 components. F2 in X, F2 in Y, F2 in Z. Okay, I am done with F1 and F2. I am done. This is F1 values. We have values. And this is F2. I'm assuming the values F1, Fx, Fy, Fz. The resultant force is given. Your resultant force is given as a vector equal, oh my goodness, negative 100 K. Keep in your mind, this vector, which is very small, originally looks like this. 0I plus 0J negative 100K. This is the original vector for your resultant. That means the X component of your resultants equals 0. The Y component of your resultant equals 0. The Z component of your resultant equal negative 100. That makes sense? That makes sense? This little vector, negative 100K, represents originally something looks like this. But I deleted or I removed the 0 and 0. So keep in your mind, the X component of your resultant originally equals summation of all X component. Keep in your mind, we have two, this one and this value. So I can quickly give you what are these values. Let me do it for you. So we have 60 times cosine 50 times cosine 30. This value equal negative 33.4. 60 times cosine 50 times sine 30. This one equal 19.3. And this one 60 times sine 50. I got negative 45.9. So I can say this component plus this component. So F2x plus negative 33.4. This is the two components. If you add them together, the final answer will be 0. Because the X component of your resultant equals 0. So I can say the X component of your force will be 33.4. This is the first one. The Y component equals 0. This Y component originally equals summation of all Y components. We have two Y components, this one and this one, 19.3 and F2Y. So F2Y plus 19.3, the summation equals 0. So your F2Y will equal negative 19.3. The Z component originally equals summation of all Z component. So we have Z component here, this one and this one. So F2Z negative 45.9. Summation of these equal negative 100, which is given. So I can figure out the Z component of your force will be negative 54.1. So looks like by the end, I can figure out the three component of your force F2. We will have 33.4. We will have negative 19.3. We will have negative 54.1. These are the three components of your force. Fx, Fy, Fz. If you would like to figure out your force itself, F2 as a force equal square root for 33.4 square plus 19.3 square plus 54.1 square. You can get your force. Your force will be under square root 66.4 pound. If you would like to figure out the angles for this force, which are not given, nothing is given about F2. If you'd like to figure the angles, alpha, beta, gamma for this angle, for this force will be inverse cosine, inverse cosine, inverse cosine, your x component divided by the force. Your y component divided by the force. Your z component divided by the force. Inverse cosine, inverse cosine, inverse cosine, you can get your angles. Does that make sense?